So the goal, we're on lesson 13, is to investigate what we can learn from graphs that represent exponential functions. So if by the end of the lesson, you can explain the meaning of the intersection of the graphs of two functions and know 2 points on a graph of an exponential function to make the equation for it, then you'll have met the goal. So I'm recording right now, just like always. Puzzle piece is lesson 13. And we are doing our mid-unit 5 quiz today. The mid-units are all over everything so far. So not like the most recent lessons necessarily, just everything up until this point from unit 5. It's only 6 questions, so that's why you only get 30 minutes. 5 minutes per question is really generous. Know that like on the ACT, it would be 1 minute per question. So that's why we're like slowly shortening the time. You do have to finish a timed assessment in the time you're given. Like sometimes I have some kids that are like, oh, I just need like 1 more minute, like my time ran out. Like, sorry, if it's not in there, it's not in there. It is what it is. When I proctor the SAT and ACT, if you continue writing after time is called, they just dismiss you. So back to the warm-up. If A, which one doesn't belong, we're going to take a class poll. So raise your hand if you think F of N doesn't belong. Raise your hand if you think G of N doesn't belong. Raise your hand if you think H of N doesn't belong. Raise your hand if you think J of N doesn't belong. Okay. So majority rules, most people think that H of N doesn't belong. Someone who raised their hand, give me a reason why H of N doesn't belong. Damon? There is no exponent. All the other ones have exponents. So what does that mean about this one? It doesn't what? Well, yes, it doesn't belong, but if there's no exponent, that means it is not exponential. All right, it is not an exponential function if there's no exponent. The variable should be the exponent. Or yes. What is it? It is a type of function we've seen before. It's not exponential. It is linear. Good. It's in the form y equals mx plus b. It might be in a different order, like b plus mx, but if you graphed it, it would be a straight line. So it's linear. Now, so we did that one. Someone give me a reason why J of N doesn't belong. Because it's 1/2. What does that do to the graph? So all the other ones don't have a fraction. That's true. What does it do to the graph if the B is a fraction? Good. So it is the only one that is exponential decay. And just because it's a fraction doesn't necessarily mean it will be decay. It has to be a fraction less than 1. So you can have fractions more than 1. All right. So G of N, that person, why do you think G of N doesn't belong? Only one that has A as 2. All the other ones have A as what? Good. Even the linear one, its starting amount is 8. So your y-intercept is your starting amount. Also your A for exponent. Huh? Well, if you've noticed the trend for these, What's the trend for like all the which one doesn't belong? Usually there's reasons why each individual one could not belong. So we found the reasons for these three. Someone tell me why f of n doesn't belong, even though no one really thinks about it. Why could it not belong? Landon? Because it is the only one where 2 is a base for the exponent. All right. So you can find reasons why any of them don't belong. Any questions on that exercise? All right, but making those observations is good. Knowing the difference between linear and exponential, especially, is like the main part of Unit 5. All right, so moving on to what is actually on your paper. So here is a graph representing an exponential function, f. The function f gives the value of a computer in dollars as the function of time, measured in years since the time of purchase. In your groups, you're gonna answer all these parts. Maybe just let's start with the first 4 parts to kind of chunk it. So figure out the purchase price of the computer, the value of f when x is 1, the meaning of f of 1, and how the value of the computer is changing each year. Do that. It's this graph that you're using. With lucky number 8, what is the purchase price of the computer? 8 is here. Doing for the 2 minutes that we will figure it out. Like this, well, we didn't ask any questions, so you can't use that as an excuse. How can you find the purchase price of the computer using a graph? Just this table. If this is the graph of its cost over time, then what did it start at? So you think the price of the computer, they bought it for $0? So then where did it start? What was the original price of the computer? 400. 400, good. Where do I look at for that table 8? On the y-axis, where it touches the y-axis is your starting amount. All right, when x is 0, that's your starting amount. So 400 is the original purchase price. Do computers usually like increase in their value the longer you have it? No. No, so that's why it's decaying. Good. Table 1. What is the value of f when x is 1? All right, 200. Anyone disagree with that? All right, so here's how you can tell. It says when x is 1. What is the value of f? So remember, for function notation, f of x equals y. If they want it to be when f is 1, find 1 on your x-axis, which would be halfway between 0 and 2, right? So maybe let me make it a little more halfway. And then find where it touches on your graph. So about here. X is 1, y is what at that region? Good. So that's how you can figure it out from a graph. Sometimes they give you an equation and you have to plug it in. Sometimes they give you a table and you have to find it on the table. When you have a graph, you find your x, find it on the graph. What's that y? And that's your output. All right. Table 2, you'll do the next one. So what does it mean? We know f of 1 is 200, but what does that mean in this situation? So the 1 is 1 year after they purchased. So 1 year after purchase. And then what does the 200 mean? Okay, good. So 1 year after purchase, the computer is worth $200. All right, not 200 years after the purchase that it's worth $1. Okay, you need to be able to read it. X is time usually, so that's time in years. And Y is dollars. Table 3. How does the value of the computer change each year? Okay, say something. I can't do anything with just silence. It does decay, so that's good. By how much is it decaying by table 4? Okay, well, let's throw that out there. So minusing by 75%. Anyone disagree with that? So going from, and you could make a table if that's better for you. So at 0 years, it was $400. At 1 year, it was $200. At 2 years, it was $100. Is it going down by 75% each time? Going down by 50%. So it's decaying by 1/2 or 0.5 each year. All right, that's what it's decaying by each year. You have to look at years that are right next to each other. Otherwise, let me think. No, yeah, you have to look at years that are right next to each other. And potentially find the common ratio if it's not clear that you're going down by 1/2 each time. So to find a common ratio, take like one of the values, divide it by its previous value. What do you get? 100 divided by 200 is 0.5. So that's what we're multiplying by to get to the next one each time. You can also say that it's decaying by 1/2, because if it's 1 minus 1/2, what do we have left? 1/2. So you could still say it's decaying by 1/2. Good. Any questions on that? All right, I think the 75% we might have gotten if we were not looking from 0 to 1, if you were looking from 0 to 2, but look at years that are right next to each other so that you can find the common ratio. We'll add you to the line. You'll be after Julian. All right, now that we've answered those two, or that chunk, answer the last two. So make an equation that defines that function. So practicing making equations from graphs, and find the value of f after 10 years. Will it reach 0? So figure that out with your groups. I'll give you a minute. Table 6. Did you happen to come up with the full equation for E? Or I think that's second table, but still I'll ask it too. Did you guys happen to come with the full equation? Okay, then table 5, tell me what is like my standard exponential function equation? That's table 5. No, just be like the basic equation. So like how, stop talking. How when linear functions, linear are y equals mx plus b, what are exponential functions? Hold on, there's still people talking. Like just because we are talking doesn't give you permission, like we can still hear you. Alright, sorry, Ian, what were you saying? So that's function notation. Perfect, so that's like our normal exponential function. That should be our starting point. We have to tell us to make an equation in this unit, and you know they're multiplying each time to get the next number. That should be like your go-to. And all you need to be able to identify is your A and your B. So table 6, what is my A of this function? What does A stand for, table 6? So what is my initial value in this problem? 400. Table 7, what is my B going to be? So 400 is the A. We want the B now. What are we multiplying by each time? Good. So times it by either 0.5 or 1/2, same difference, and then put it to the x power. That's what makes it exponential. So that's your equation. That makes sense? Good. All right. So now that you have the equation, everyone should be able to calculate this next part. So whether the value of f will be 0 after 10 years. Yes or no? Class. I'll ask the other class. No. Okay, why no? No, at 10 years, it gives you a value that's pretty close to 0, but it's point what? So that's still, and if we're talking about dollars, that's still like about 39 cents, right? That's still not 0. If you don't know how we got that, what did I have to plug into our equation? Table 8, what did I have to plug into the equation to solve that? Let them do it, it's fine. That's why we have to pay attention. Class, what did I have to plug in to solve for that answer? Replace the x with 10. X is time in years, right? It said that in the problem. So if it wants me to see if the value of f will be 0 after 10 years, then plug in 10 for the x. And then just throw it on your calculator. So then 400 times 1/2 to the x or to the 10, that's why we got the 0.39. That's all you have to do. Questions? All right, we're going to try these next 2, and then I imagine then we'll quiz after. So here are graphs of 2 exponential functions. For each, you're going to write an equation that defines the function. So more practice making the equation from the graph. Once you do that, you're going to find the value of the function when x is 5. So make the equation, find the output when the input is 5. I'll give you 2 minutes. So for the first graph, is that an exponential function or a linear function? Exponential because is it a straight line?
No.
So then it must be exponential, like a curve, and it's either increasing or decreasing at a really fast rate. So what's my standard equation for exponential? Good. So you really only need to be able to identify 2 things for making the equation. The A, which stands for, what's my initial amount on the first graph? More than just Brian, please. Everyone look at it. What's my initial amount on the first graph? 5. You have to look at the y-intercept. So 5 is my A. So even though there's some in the negative, the y-intercept is your starting point, because that's when x is 0. And what is my B going to be? Which in this one, what am I multiplying by to get the next year? Not 1.5. 3. If you need to make a table to organize it, then do that. We have 0, 5, 1, 15, 2, 45. You may be able to see the pattern, maybe not. If not, just find the common ratio. Take one of the values, divided by its previous value, and that will be your B. What's 15 divided by 5? So that's what goes here. And then to the x. So that's your equation. Questions there? All right, when it says find the value of the function when x is 5, what do I do? What do I do when they ask me to find the value when x is 5? Replace the x with a 5. And then if I were you, I would just put that in my calculator. 5 times 3 to the 5th power. I would put it in all at once. Otherwise, do the exponents first. And that's 1,215. Questions there? Okay, I'll write it up here. So y is, and I'll write it in function notation even. So when my x is 5, my y is 1,215. We have no clue what this problem's about, but we should also be able to interpret when the input's 5, the output is 1,215. All right, next graph. What's my A value for the next graph? Good, so we're looking in the right spot at the y-intercept, not the 40, okay? Because the x is probably time. Doesn't tell us what it is in this one, but say it's like years since 2000 or something. Then that -1 would be the year 1999. So it is possible to have like negatives if that's what they're talking about. But the A will still be when the x is 0. Your y-intercept. What's my B going to be? All right, so here's a way that you could get this wrong. If you're looking at it from 0 to 20, and then you try to find the common ratio from the coordinate 2, 5, that won't work. The way that you find common ratio is it has to be the previous term. Well, the previous year before 2 would be 1. It doesn't tell us what that is. I mean, we can assume, but we all know like what assuming is. So pick another x that's near the 0 that you do have. The -1 and 40. And find the common ratio there, because that would be the previous term, wouldn't it? So then 20, the previous term is, And what's 20 divided by 40? 1/2 or 0.5, same difference. And then that'll be for that. All right, if you use your graph, what is 10, or not 10, I gave away the answer. What's the Y value approximately? Good. So you could have done that, but I don't like using approximations to find like concrete values. All right, and that makes sense. So it is decreasing by 1/2 each year. And then to find the Y when X is 5, just plug it in. And I already did it earlier, so I already know the answer. But it would be 0.625 if you did the math for that. Plugging it in when X is 5. All right, questions, comments, concerns? We're going to take our quiz now. So the quiz is in the Secure Illuminate. If you're not using the Secure Illuminate, I will know. I can tell the difference on your screen. So get your Chromebook out, log out if you logged in.